Hello everyone, my name is Michaela Relford and I'm a second-year mechanical engineering major at the Georgia Institute of Technology. Today I'm going to be discussing Lab 2 for my Physics 2212 class. This lab follows the same procedure as Lab 1. We rip apart two pieces of Scotch tape so that they become charged, and then we observe interactions between objects of the same charge, opposite charge, and neutral charge. In Lab 1, we used the data that we collected from this to calculate the charge on the two pieces of tape by modeling them as point charges. But in Lab 2, we are going to use Python and the same data that we found in order to determine the charge on the pieces of tape modeled as a line charge. Just like in Lab 1, we charged pieces of tape by ripping them off of one another and observed interactions between the tape and other charged or neutral objects. As you can see by the data table that's on screen now, the tape repelled each other, which makes sense. We can assume that they have the same charge. The tapes also attracted neutral objects, which is because the neutral objects will have induced dipoles when they interact with charged objects. And the tape was attracted to a negatively charged plastic pen, which means that we can infer that the tape is positively charged. Now in Lab 1, we used this information and we created another experiment where we set the two pieces of tape perpendicularly to one another so that they floated on top of each other. And then we modeled the tapes as point charges so that we could calculate the electric force and then we could calculate the charge. Instead of modeling the two pieces of tape as point charges in this experiment, we used Python so that we can model them as lines of charge, which will hopefully be more realistic to reality. Using the variables that are on screen now, we can calculate the force of gravity acting on the pieces of tape. We know that the magnitude of the force of gravity is going to be equal to the magnitude of the electric force. We can also ignore air resistance, and we can assume that the two pieces of tape have the same amount of charge that is evenly distributed along the entire length of the tape. We can start the code by declaring a few variables, and then we can define a function which can calculate the electric field of a charged particle. This will make calculations much easier along the line when we start iterating through the portions of a line of charge later. Now, we can iterate through each piece of charge in the charged tape in order to find the electric field and the electric force. You'll notice that when we use the charge for Q that we found for the pieces of tape when we modeled them as point charges, that the magnitude of the force of gravity and the magnitude of the electric force are not equal to one another. But since we know that the interaction between these two forces are equal and opposite, we know that the charge that we're using for the line of charge can't be right, so let's mess with that a little bit. The new charge that we found for the tapes when we model them as line charges in GlowScript is 6.982 times 10 to the minus 8 coulombs. This is much larger than the charge that we found for the point charge. When we run this code using the correct value for Q, or the charge on the two tapes, the white arrow pointing up is the electric force acting on tape B, which is the top tape, and the yellow arrow pointing down is the force of gravity acting on tape B. All of the little green arrows are the individual electric forces that are going on, and when you sum them together, you'll get the big white arrow. The red line of charge at the very top is meant to model tape B, which is floating over tape A, which is modeled by the blue line of charge. There's not much separation going between them. In fact, there's no visual separation at all. But this is because the separation distance between the two pieces of tape is so minuscule that it sort of clips between the two spheres. So realistically, they are separated, but in the program, that's just not modeled correctly. We found that when you model the tapes as lines of charge rather than point charges, and hold that the magnitude of the force of gravity and the magnitude of the electric force is the same as it was before, that the charge for the line charge is much higher than the charge that we found when we modeled the tapes as point charges. These values differ because now we're taking into account the charge being distributed along the length of the tape, which means that the charge that we found here is likely to be much closer to the actual charge in real life. In conclusion, we were able to use a few simplifying assumptions to perform calculations so that we could better understand the nature of some of the electric forces acting on two charged pieces of tape. But since we were able to perform these calculations in Python rather than by hand, we were able to model them as line charges, which is far more accurate to real life. So thank you all for watching, and I hope that you have a wonderful day.